So this is my capstone project, a kaggriculture farms up guardian agent. It is an autonomous farming resource management agent that decides whether the best daily action is to irrigate, inspect, fertilize, harvest, or wait. So the goal is to demonstrate an agentic workflow with tools, memory, guardrails, evaluation, and trace logging. Um, This section is about so this table maps the project to the course concepts. So the project includes like ADK style, multi-agent design, and then CP server, security guardrails, agent tools, memory and context, evaluation and deployability. So this notebook runs the core agent logic, while the GitHub repository contains the full project files. Here is so the architecture follows a standard agent loop. So the agent observes the farm state, calls tools, plan the best action, validates the action with guardrails, store the results in memory, and then evaluate the decision through traces and test scenarios. Here I define here I define the farm state and the allow actions. So the agent can only choose from 5 safe actions. So it's irrigate, inspect, fertilize, harvest, or wait. The tool estimates irrigation need, weather risks, disease risks, action cost, and expected yield impact. So this keeps the agent grounded in structured calculation instead of relying only on the free text reasoning. So this section adds like memory and safety. So the memory stores recent actions and decision traces. The guardrails validate every proposed action before it becomes final. For example, the system blocks irrigation when there is not enough water, block blocks the harvest if the crop is not mature. Um, Also, it blocks harvest. I mean, if the crop is not mature, it blocks actions that exceeded the budget and blocks invalid actions outside the allowed list. So this is the core agent. It observes the current state, calls the tools, proposes actions, applies guardrails, and records the final decision. So this makes it more than a simple script because it has an agentic cycle. Uh, so once like observe, use the tool, decide, validate, and remember and evaluate. So here are so these 5 scenarios demonstrate different farm conditions. In one case, the soil is dry and the agent recommends irrigation. Here. In another case, disease signals are high and the agent recommends inspection. The second. In another case, the crop is mature and the agent recommends harvest. This one. This shows that this agent adapts its decision based on the state. So there is one guardrail example, and it's this one. So this is the best guardrail example because the planner proposed irrigation because the soil is dry, but the guardrail blocks it because water available is too low. So this demonstrates that the safety layer can override the planner before an unsafe or possible action return. This section evaluates the agent against expected actions. Um, each scenario has one expected final action, and the notebook checks whether the agent match it. So this is very important because an agent should not only generate an answer, but it also should be testable and measurable. So here we see like scenario accuracy is 100%. Uh, so this observability trace. So these trace logs provide observability. It records the timestamp, proposed actions, final actions, and guardrail decisions for each run. So in production system, this type of trace would be critical for debugging, monitoring, and improve the agent. Uh, the repository also includes the ATK style multi-agent design. The idea is to separate responsibilities across agents, a coordinator agent, and agronomy agent, and a resource agent. So this makes the system more modular and closer to the production multi-agent architecture. Also, yeah, the repository includes an NCP server that exposes the farm tools as scalable capabilities. So this allows the same tools to be used by agents runtime through a standard interface. So which makes this system easier to extend and integrate to other systems. The deployability. So this project also includes deployment files. So there is a fast API app. Also, there is a Docker file and deployment notes. So this show how the notebook prototype could become a real service that receive farm state through an API and returns the recommended actions. So the conclusion here is, the farm ops guardian demonstrates a complete agent pattern for kaggriculture. So it uses tools, memory, guardrails, evaluation, trace logging, ADK style multi-agent design, the MCP integration and deployable structure. So this current notebook is a working prototype, and the architecture can later be connected to real weather APIs like farm sensors and Gemini powered reasoning. So that's my capstone project, K-Culture Farm Ops Garden Agent, a safe and testable autonomous farm resource management agent. Thank you.